We usually imagine a black hole as a silent predator, an empty void swallowing stardust with the efficiency of a cosmic drain. This follows the classical model of collapse. When a massive star dies, its internal pressure fails, and gravity crushes its remains into an infinitely dense singularity. This creates the event horizon, the perimeter where the gravity is so steep that time stops, and light cannot find a path out. But the vacuum cleaner model is a simplification. Black holes do not exist as solid physical objects within space. Instead, they are extreme geometries. They are regions where space-time is warped so severely that the resulting environment contradicts every rule of classical motion. These are realms of extreme gravitational friction and temporal distortion, where the laws of physics are pushed to their breaking point. It seems logical that a region of infinite gravity would be easy to enter. In practice, falling into a black hole is one of the hardest maneuvers in the universe. This particle shows the conservation of angular momentum in action. Like a ballerina spinning faster as she tucks her arms, matter accelerates into a tighter orbit. Approaching light speed, it hits a physical speed cap, creating a blazing roadblock just outside the event horizon. This orbital traffic jam generates immense friction, heating the matter to 10 million degrees. The pressure is so intense that atoms are stripped down, shedding up to 40% of their mass as raw, radiant energy. This is the accretion disk. When these disks are fully fueled, they become quasars, structures that radiate with more luminosity than 1 trillion suns. The spinning disk generates magnetic fields that act as a high-pressure valve. Instead of swallowing everything, the black hole channels matter into relativistic jets, firing particles across entire galaxies at near light speed. The boundary functions as a high-velocity engine of friction, rejecting far more matter than it consumes. If you move past the heat of the accretion disk, you encounter a second paradox. The universe's most effective trap can be used as a kinetic power plant. This wireframe illustrates the ergosphere. As a black hole rotates, its mass drags the space-time grid. Within this zone, reality's fabric moves faster than light. An object inside isn't just falling, it's forced into motion by the rotation of space itself. In the late 1960s, Roger Penrose realized this effect could be harvested. He proposed that by dropping a mass into this swirling space and firing a rocket at a specific trajectory, a ship could be ejected with more energy than it started with. The extra velocity is stolen directly from the black hole's rotation. By utilizing the movement of spacetime as a planetary walkway, a region of zero escape functions as a source of near-limitless energy. While black holes appear permanent, they are governed by a countdown. They are slowly evaporating. Stephen Hawking used quantum mechanics to prove that energy, and therefore mass, must be able to leak out. This graph represents the quantum vacuum. Even in empty space, quantum fields vibrate, causing particle pairs to split and immediately annihilate each other. But the event horizon disrupts this. Gravity pulls one particle in, leaving its partner to escape as Hawking radiation. To maintain the conservation of energy, the black hole must pay for the escaping particle. It loses a fraction of its own mass to the vacuum, causing the entire structure to slowly shrink. Over trillions of years, this leak accelerates. Every black hole is destined to vanish in a final, massive release of energy. These regions function as high-energy turbines, governing the distribution of matter and the life cycle of galaxies. But the math behind these turbines, first explored by Albert Einstein, suggests an even more unsettling conclusion. Einstein's field equations state that the curvature of space and the presence of mass are mathematically proportional. We usually assume mass is the cause, the foot that creates the footprint of curved space. However, Hawking radiation shows that when you reduce the curvature of space, the mass of the black hole vanishes with it. If the mass cannot exist without the curve, it raises a difficult question. Is matter the creator of space, or is physical matter merely a secondary effect of space being bent? Black holes are more than just gravitational anomalies. They are the points where the relationship between matter and space is laid bare, forcing us to reconsider the origins of the physical universe.